In this session, the lecture session, this is the last one. That is the 5th lecture sessions. Again, I will elaborate a few other important issues related to the GIT based production and inventory control system. Now, one such the system I am going to discuss at this point in time, that is the signal Kanban system. And then other types of Kanbans as the time over the time, the many companies proposed the many variants of the Kanban system. So you should be aware of these different types of Kanban system, and under what condition which type is recommended, that also you must know very clearly. And we refer to different types of pool systems. As I have already pointed out, that entire Kanban system is based on the pool systems of dispatching. Essentially, it is a kind of dispatching system. So it's not the push system. So the first thing what you need to do, that means entire manufacturing systems or the production system is to be converted from push to pull system, and then you start thinking of say the using the GIT based tools and techniques. So what are the benefits of the GIT based production and inventory control system in specific terms? You also must be aware of. So this we will point out, and obviously there could be some barriers, there could be some problems in general category. The general problems you may face while you go for the GIT based systems implementations. So you should be aware of, and this we say the barriers to GIT implementation. So these barriers you must know in advance, so that it becomes easier for you to take effective the preventive measures to overcome those problems. Now let us talk about the signal Kanban system. Now, as I have already pointed out, that in the original the 2-card the Kanban system, what we are assuming? We are assuming that the setup time is negligible. Yes, there are many the manufacturing processes where the substantial reduction in the setup time is possible, and so before you implement the GIT based systems, the certain preconditions you have to fulfill. So one such precondition is the reduction substantially of the machine setup. And for machine setting up a system set of the controlling or the setup reduction, you need to take a systematic approach. Particularly, you must know that with respect to a particular the item which you are going to produce on a machine tool, and the kinds of the machineries you are having, or the kinds of holding devices you have. There are varieties of holding devices. So what sort of the internal setups you have, and what sort of external setup you have. Now for the internal setup means those kinds of activities you need to do for setting up when the machine is idle. That means the productivity, you can't get any level of productivity while you are doing the internal setup. Now, but the external setup is the kinds of adjustments you do while the process is on. So as such, during the external setup, there is the no hampering of production, and that's why the productivity is maintained. So entire the exercise should be for reduction of setup, that how to convert, what are the ways and means with which the internal setup elements be converted into external one. So there are the several case studies, and for setup reduction. So I suggest that you refer to those case studies. In course of time, maybe we may refer to the certain the cases where you will come to know that in a manufacturing setup, so what are the the practitioners, they apply various sorts of approaches, and they are all the practical to reduce the setup time. That means essentially converting the internal setup into the external one. So this is one category. So wherever the setup time reduction is possible, you go for it. That means you go for the say the two Kanban card based say the Kanban systems. But there are processes where the setup reduction is not possible. That means setup time is substantial in comparison with say the processing time, or in comparison with other elements of say the throughput time. So so what to do? Can you not apply say your Kanban systems for such cases, like say the press operations, for forging operations, for die casting operations? Yes, you can do, but in that case you need to the modify your original say the Kanban systems, and this modified version is referred to as a signal Kanban. Now here is just one the simple representation of the working of a signal Kanban. So what you have here, in fact, like say there are two types of the Kanbans you are referring to, and one particular Kanban, it actually shows the position of raw material ordering signal Kanban. So now this is the lot size, and usually what happens that in the original Kanban systems, as soon as you send say withdrawal Kanban, and at the same point in time you send your production Kanban to the previous stage, so 1 to 1. So here what is important is that here, suppose this is the withdrawal Kanban, so this Kanban or say the container goes to the next stage, and as it goes to the next stage, you are not sending any production Kanban to the preceding stage. Similarly for the next one, similarly for the third one, similarly for the fourth one. But if the fifth one goes to the next stage, okay, now this is an indication, that means this position of the raw material ordering signal Kanban is shown. That means the fifth Kanban goes to the next stage, and immediately what you do, you send this the raw material ordering signal Kanban to here, that means the Kanban box, and from the Kanban box it goes to say it goes to the raw materials inventory storage systems. That means now you prepare your production systems at the preceding stage, and for producing this item, what you need, that is the raw material. And before you start producing, make sure that the raw material is made available. So that's why first you send the raw material, the instruction to the raw material inventory storage. So it gets the instruction, okay, as soon as it gets this Kanban, and then it sends the raw materials to the work center. That means raw material is ready. Now in the next Kanban, that means the next container, when it goes to the next stage, that means this is the sixth one, that means 1, 2, 3, 4, 5, from fifth one is for the raw material ordering signal Kanban, and the next one is the position of the production ordering signal Kanban. That means the material is ready, but you need to process the material, but there must be an order for the production, and this order or this authorization is given by this signal Kanban. That means it is referred to as the production ordering signal Kanban. So as soon as you reach to the sixth containers, so you just you send the container to the next stage, but simultaneously you detach this card, you send it to the Kanban box, and then from here it goes to the next Kanban box, that is B, and then it goes to the work center. Now by the time it reaches over there, already the raw materials is waiting to be processed. So ultimately the production is made, and then the container wise you send the production quantity to at this stage. So this way, what happens, so the entire cycle is completed. So what is important is, as a student, as a learner, you must be able to understand that what is the starting point, and how you get back to the starting point once again, and in the process the entire cycle of operation, and you must not have any doubts and understanding that what are the factors affecting say the activities in this cycle. So one cycle you need to explain, and I am trying to explain the one cycle of operations. Okay. So now there are several notations. So for the raw material signal Kanban, we have this rectangular card, whereas for the production ordering signal Kanban, we use a triangular card. Okay, as far as the shape of the card is concerned, and this is the post A, that means signal Kanban receiving post, and this is post B, that means signal Kanban ordering post. So several kinds of notations we have been using. This is the lot size, and this is the raw material inventory storage, and this is the work center. Okay. Now, so here what are the parameters of a signal Kanban system? So the first parameter is you need to determine the lot size, point number 1. What is the point number 2? That means the next important parameter, and the value of that parameter you need to know, that is basically the position of raw material ordering signal Kanban. Okay, so the given data set, definitely you can determine this, and I will tell you that what are the the data you require to determine the lot size, to determine the position of raw material ordering signal Kanban, that is the second parameter of this system, and the third parameter is the position of production ordering signal Kanban. So once you determine their values in a given system, now obviously you run the signal Kanban systems, and you may question that why do you have a lot size substantially greater than 1. So here what is this lot size in terms of the number of containers? That is 1, 2, 3, 4, 5, 6, 7, 8, 9. That means your lot size is the 9 containers, and usually the container to container there is no change in the size of the container. That means how do you define the size of a container? This is in terms of the number of units of a particular, so the item that you can hold, is okay, that you can keep in a container. So that is the size. I have already mentioned that usually in a typical the Japanese production systems, so this container size could be 50, 100, 150, 200, like this. Okay. So so this is, so the first is the lot size in terms of the number of containers, and similarly the position of say production ordering signal Kanban in terms of say the number of the Kanbans. That means here 1, 2, 3, 4, 5. So as it shows in this particular diagram, in this particular figure, you will find that the position of production ordering signal Kanban is 5, and usually position of say the raw material ordering signal Kanban is 5, whereas the position of production ordering signal Kanban is 1, 2, 3, 4, and usually the next one to say the material raw material ordering Kanban, the signal Kanban, usually the next one becomes the position of the production ordering signal Kanban. Okay, so this is all about signal Kanban. Now there are 3 important parameters of these systems I have just mentioned. You can note down. The first one is the lot size, minimum lot size per setup, that you have to ensure. So this is the condition, and while you determine the lot size, what you can do, actually you can use the traditional approach. That means what you need to do, that means the availability of the machine tool you must know. This is point number one. The second one is the in a particular shift, okay, say in a day, so how many the possible parts you are producing, and for each part what is your average setup time. So this you must know, and the available time, like say you say that my the utilization is on an average is 80%, that means 80% of the available time is made available, whereas the remaining 20% time is say you use for the setup. So how much time you spend or you are supposed to spend for setup in a day or in a shift. So this you must know, and then what is your demand for each setup, and what is the demand for each part. Suppose there are 3 or 4 parts you need to produce, same machine, and for each part what is the setup time. So what you once the demand is known for each part and the setup time is known, obviously you can determine against each setup how many parts or how many units you are going to produce. Is it okay? Against each setup and for each part, and suppose the total number of units you can produce, that is say for each part it is say suppose it is say some 800, and your say the container capacity is 100. So obviously your lot size in terms of the number of containers is 8. If it is say 850 and your container size is 100, obviously it is actual value is 8.5, and now what you do, you must have for the 9 to make it a whole number or say the integer. So this way you calculate the lot size, and for determining the position of the production ordering Kanban, or for determining the position of the material ordering Kanban, what actually you are supposed to do, that means you already know that how to determine the number of Kanbans. So a particular formula we have used as given by the Toyota say the motor company. We have already studied that one, that is y is greater than equals to means there is a formula like so the demand rate the into say your the safety factor into the lead time and divided by the container capacity. So this formula you are using, and when you assume that the deterministic model is applicable, so you can use that that particular formula, and you can determine against a particular data set that what is the position of production ordering Kanban and what is the position of material ordering Kanban. Like we have stated in the figure, if you refer to the figure, what you will find that the position of the production ordering Kanban is 4, whereas the position of the material ordering Kanban is 5. Okay, so when data pertaining to available production time, so these are the data you must ask for to determine the values of all these 3 the parameters of a signal system, a signal Kanban systems: available production time, machine utilizations I have already mentioned, average setup time per part of the product. Okay, this point already I have mentioned. Kanban cycle time, this is very important. I have already mentioned that the cycle time. So the cycle time for say the material ordering signal Kanban. Okay, so start point and the end point. So what is the time the elapsed, total time elapsed, that is basically the Kanban cycle time. So obviously for material ordering so ordering signal Kanban, the the total the Kanban cycle time could be 4 hours, whereas for the production ordering signal Kanban, okay, the signal or say the Kanban cycle time could be less than 4 hours, maybe 3 hours or 3 hours and a half, like this, or say 2 hours. So this the timing, what we are assuming that this the timings do not change, or what you can do, that means you can assume so the maximum possible values, okay, and but make sure that when you say it's a maximum possible values, never you include the factors related to inefficiency. Then if you do this, then the entire purpose of installing or implementing GIT based production system, okay, the entire purpose gets lost. Okay, so you have to be when you determine this cycle time, this is very important, the Kanban cycle time. That means this cycle time should be as tight as possible. Okay, if you make it very loose, what happens that because of these reasons the Kanban system may become useless. Average demand, this value must be known. The safety factor I have already mentioned, that means the value of say the alpha, that is very important, that is what is the possible value of alpha. Initially it could be 0.3, 0.25, but they make sure that the value of alpha should be as minimum as possible. That means from a disorderly system it is becoming an orderly system. That means how do you define an orderly system? That means your production and inventory control system, you have a system which can which can protect so this your production and inventory control systems from the external disturbances. Okay, so if you can achieve this, obviously the value of alpha should be very less. So the container capacity, this is known, and these data are made available. The values of the above stated parameters can be computed. So later on we can have a number of numerical problems on this. Now before I conclude my lecture sessions on the GIT based the production systems or manufacturing systems, now I also should refer to, or I must say tell you something, means some characteristic features of other types of Kanban systems. So in specific situations, Kanbans of special types can be designed and used. Is a special purpose. Okay, so these two kinds of the systems which we have explained, which we have already explained, one is the Kanban systems, and the second one is the signal Kanban systems. Now these two systems you can apply in general conditions. That means those are basically referred to as the general purpose. But you may face the special situations, and whenever you face special situations, you have to propose the new kinds of say the Kanban systems. So the following specific type Kanbans are used. First one is the express Kanban. Okay, so what does it mean? That means it actually monitors and control the shortage of parts occur. Okay, it's like say suddenly due to many reasons the shortages are occurring. So you need to use this sort of express Kanban. That means now it becomes an important say very critical Kanban. So you need to produce as per the express Kanban specified the quantity. Emergency Kanban, when there are defective units, the systems what we are assuming that the defective units okay, you must not produce, and if you produce it, don't include it in the flow of the materials. You must have the ways and means, you must have a system for its separation from the basic the material flow system. So when there are defective units, the machine failure or fluctuation in production quantities, the emergency Kanban you need to use. Through Kanban, it's like through ticket. That means when two or more work units are located very close to each other. So what do you do? As they are physically located close to each other, so instead of having, suppose there are three such systems you have, they are very close and everything is visible from at any stage. So instead of using say 3 specific Kanbans, why don't we use just one? Okay. So this is referred to as the through Kanbans. Like we have the through ticket. Now you also must be aware of at this stage what are the different types of pull systems. So the researchers, the practitioners, they have they developed a number of say the different types of pull systems to meet specific objectives. And whenever you look at all these systems, you will find actually by using different types of pull systems, you are able to strengthen your systems, the pull systems, in a very effective way. So as JIT system is built on pull system, this is a necessary condition. It is designed as per the pull systems used. There may be different types of pull systems. Again, we have already defined the pull systems in a general way, whereas in specific situations you need to implement the pull system in a specific way. So one such specific the pull system is referred to as the periodic pull system, based on online computerized information processing, resulting in better system performance with reduced lead time and inventory and faster response. That means initially we assume in any Kanban system is essentially it is assumed to be a manual system, but why don't you implement a computer based system. So when you try to implement or you try to use online computerized information processing in a Kanban system, so this is referred to as the periodic pull system. So obviously there are many advantages. One advantage is reduced lead time and inventory. So as far as inventory control is concerned, management of inventory systems is concerned, so this is many a time you opt for online real-time control systems like MRP systems and all. We have already discussed. And the faster response time. Okay, this is also important in fact. And as I have told you that whenever you talk about the JIT based systems, that means waiting time must not be there. It should be as minimum as possible. Constant WIP. That means the WIP control is one of the important issues or one of the important objectives in JIT based production system. So this is, in short, this is referred to as a ConWIP system. When production Kanbans are assigned to the production line, that means the entire production line is having just one production Kanban. If there are a large number of parts and the Kanban system is considered impractical, that means if there are a large number of parts, suppose there are some 500 parts or 200 parts. Now for each part in a system, you have to use a Kanban system. Now it may become an impractical one. So what do you try to do? You try to have just one say the Kanban, okay, controlling the WIP of the entire production line. Obviously, while you design such a system, you specify that what is that constant WIP. Okay, so that value is to be specified, and once under that conditions, so you can develop or you can specify the production rate at different stages. So this is referred to as the ConWIP system or constant WIP system. Long pull system, it is also there. It is basically a combined push-pull system like this one. That means the flow of parts and information in such a system is shown is like this. That means you have process 1, process 2, process 3, and then you have the finished product, and you're starting say the system is the raw materials input section. So what you try to do, so instead of having say considering all these processes separately, you just consider all these three systems as a push system, and over this pull system, what you have, you apply the pull system. Is it okay? So is there no point, this may be treated as just one unit. So why don't you have a push system, and these three systems, these three processes are considered as one unit. So this is referred to as a combined push-pull system. Now there are many benefits a company may have if JIT based system is implemented. So these the benefits are I have already listed. So you please go through them, like say increased productivity, reduced lead time, reduced setup, and so on, like less WIP. This is an important say the benefit, increased worker and equipment efficiency, and improved quality. Now implementation of JIT based systems may be difficult in many situations. I have already pointed out. That means there are certain preconditions you have to fulfill. So a total systems approach is needed in order to achieve all the seven so the objectives or seven goals simultaneously, and hence implementation depends on the level of integration and teamwork needed. So what are the few problems? I have just highlighted a few problems, like difficulty in knowing the exact demand of an item at a particular stage in a given time period. This is one difficulty you may face. Equipment failures becoming uncontrollable. So this problem you have to tackle beforehand, and frequent changes in the production plans. That means as we have already discussed in MRP systems, that means for a certain period of time you have no other alternative but to freeze your MPS. So however, even if these problems come across with concerted effort and following principles of JIT implementation, there have been several instances where JIT based systems implemented in several functional areas like manufacturing, engineering, purchasing, marketing, quality control, and assembly. So everywhere you can implement JIT based systems as a general say the methodology. So the equivalent European systems called lean engineering and management can also be implemented. Okay, so with this I conclude this session. I hope that you have understood the details of the JIT based systems and to what extent it is able to say create a combined production control and inventory control systems. Thank you.